Good day, everyone. In this lecture, we are going to discuss glassware and plasticware that we are using in the clinical laboratory setting and in the clinical chemistry section. Okay, so we can classify our laboratory supplies based on its composition and based on its function. If we are going to classify our glassware or our laboratory supply based on composition, it can be classified as glassware and plasticware. Well, definitely, if that is a glassware, that is fragile. No? And if that is a plasticware, there is a precautionary measures in using our laboratory supplies if that is a plasticware, most especially if we are going to handle acids or bases. As we all know, this might cause damage or can cause laboratory-related injuries in a laboratory personnel or in you as a medical technology student if you're going to use plasticware for acids or strong acids. Aside from that, laboratory supplies can be classified also based on its function. There are three classifications based on its function. Number one is container and receivers. Example of this one are your beaker, no? Beaker, well, of course, your test tubes, no? Erlenmeyer, flask, no? Or flask, our flask can be classified as a container or receiver, okay? What else? We also have what we call volumetric ware. From the word itself, volumetric, we are using this for acquiring or determining a volume of a particular liquid. Okay, let's say for example, this can be your pipettes, no, your more pipette. Okay, your graduated cylinder. Okay, are some of the examples of our volumetric ware that can use, no, to measure the volume. You might be saying that our beaker can also be classified as a volumetric ware because there are also what we call graduations or there are also markings in our beaker. However, if we are going to compare, no, the accuracy of the volume of a beaker compared to our graduated cylinder, we can say that this graduated cylinder is much more accurate in use, much more accurate as compared to our beaker in terms of using, in terms of getting the volume of our liquid or our substance. And lastly, we have our miscellaneous laboratory vessels. Even though they are termed as miscellaneous, they also have their importance, no, or relevance in the clinical laboratory, particularly in clinical chemistry laboratory. What can you see in this illustration is, yes, you are correct. No, these are what we call the glasswares. Okay, basically glasswares can be classified into 5. Number 1, we have your borosilicate or silicate glassware, no, which is the most common. We also have our alkaline resistant glassware. We also have our aluminasilicate glassware. We have your low actinic glassware, and we have your Flint glassware. To start with, we're going to discuss first what is borosilicate glassware and so on. Number 1, we have your borosilicate glassware. Take note, guys, that of all glassware that we have, borosilicate glassware is the most common type of glassware. This is actually what we have. This is actually what you're using even in your junior high school or senior high school days. Why? Because it is common. Aside from that, no, aside from the reason that it is common, it has a characteristic of high thermal resistance. Okay, it has a characteristics of a high, or characterized rather. It is characterized by high degree of thermal resistance, meaning to say even though you use it for extreme high temperature, it will not break, no? Example, yung Pyrex na beaker na ginagamit natin. Okay? In the laboratory, you've been using the Pyrex beaker in the laboratory for quite some times, or very multiple, uh, na a lot of times. That's what I mean. Have you seen a beaker na nag broke or nag-break because of high temperature? Sometimes, yes, if that's too old. However, one of its characteristics is it can resist, no? It can resist uh, high temperature. Let's say, for example, the Pyrex, no? The Pyrex. Pyrex, no, can resist 515 degrees Celsius heat. So even though you're using your Pyrex for boiling, no? Let's say, for example, boiling water is 100 degrees Celsius. Okay? Kaya na pa yan. Now, having said that this is characterized by a high degree of thermal resistance, thus therefore, concentrated alkaline solutions can be stored in borosilicate glass. Why? Because they dissolve or destroy their calibration. Take note, take note of this, people of God. Borosilicate glasswares are characterized by a high degree of thermal resistance. However, no? However, concentrated alkaline solutions. When we said alkaline solutions, these are your basic solutions, right? With pH of greater than 7. All right? All right? They can be stored in borosilicate glassware. Why? Why? The reason behind that is because it can destroy the calibration. Destroying the calibration of our borosilicate glassware can affect the uh, measurement of the volume that we are going to take. Now, there are commercially available borosilicate glasswares, commercial brands, one of which is well known as the Pyrex. We also have your Corning, Kimax, or Kimball. Aside from that, yeah, the Pyrex. Okay, so we have the Pyrex, the Corning, the Kimax, and the Kimball. Now, having said that this glassware has a high resistance, we have to make sure, we have to take note that boiling or that heating, no, this glassware beyond their heat capacity, or what we call strain point. Okay? Take note, using these glasswares, borosilicate glasswares, beyond their capacity, beyond their strain point, can cause its damage. Let's say, for example, Pyrex. Yung Pyrex glasswares, ginamit mo more than 515 degrees Celsius na kanyang strain point, then it can cause damage. Pwedeng masira, pwedeng mabasag ang ating borosilicate glassware. Okay? Again, take note, borosilicate glassware is the most common glassware and also characterized or also known as the thermal resistance. Thermal resistance glassware. Okay? Moving forward to our alkaline resistant glassware. Okay? Again, from the word itself, alkaline resistant glassware, no? It can hold our alkaline solutions without using the integrity of the glassware. However, if we are going to compare the alkaline resistant glassware to our borosilicate glassware, it has a poor heat resistance. Actually, half of the thermal resistance of the Pyrex. If the thermal resistance of Pyrex is below 515, then half of that will be the thermal resistance of our alkaline resistant glassware. Example of a glassware or alkaline resistant glassware that we have is this one, the Vicor. Okay, this is a Vicor crucible, no, that can be used in the clinical laboratory. Aside from that, you also have here your cuvettes, no? These are what we call cuvettes. CUVETTE, no, that can be used in spectrophotometry, okay, that can resist alkaline, okay, or have a high resistance to alkaline solutions. Next in line is we have your aluminasilicate glassware. Take note, guys, that aluminasilicate glassware is strengthened chemically rather than thermally. So bakit siya strong? Not because of its thermal resistance, but because of its chemical composition. Take note, no, take note, people of God, that aluminasilica glassware is 6 times stronger, or sana all, 6 times stronger, no? 6 times stronger than borosilicate, silicate rather, no? Borosilicate glasswares. Again, take note, aluminasilicate glassware is 6 times stronger than borosilicate glassware. Okay, the popular brand of our aluminasilicate glassware is what we call the Corex. And one of the good thing is since it can resist uh, clouding and scratching, okay, much more expensive than the Pyrex. Okay, take note, people, that these aluminasilicate glassware, they are alkaline resistant glassware and therefore can be used best to handle strongly alkaline solutions. Kanina, si borosilicate glassware, if we're going to compare, no, balikan natin, let's recall. Borosilicate common pero cannot hold alkaline solutions because it can lose its calibration, leading to the loss of the integrity of the glassware. Okay, aluminasilicate is stronger 6 times than our borosilicate. And aside from that, it is a alkaline resistant. Having said that this is an alkaline resistant, thus therefore, it can be used as a best glassware in handling alkaline solutions. Example of alkaline solution is your sodium hydroxide solution that can be used in titration processes. Okay. Next, aluminasilicate glassware possess half of the thermal resistance of the borosilicate glass. Kasi nga, sabi natin, this is strengthened chemically but not thermally. Next in line is we have our low actinic glassware. This is sometimes referred as the amber bottle. You're familiar with this one, okay? This is the amber bottle that is used in the clinical laboratory. Example of a low actinic glassware or example of a chemical that can be seen in a amber bottle is your sulfuric acid. I don't know if you were able to, I believe that once in your life you were able to use sulfuric acid in one of your experiments in your minor chemistry courses. The bottle wherein your sulfuric acid is contained is a amber bottle. Okay, why an amber bottle? A glassware that are highly thermal resistant with red color as an integral part of the glass. Why red? That's the question. Bakit niya makula? Okay, the reason behind that is because of the density of the red color. So what is with the density of the red color? The density of the red color is adjusted to permit adequate visibility of the contents, giving its maximum protection from the light. Okay, take note. A amber bottle is usually colored red. Why red? Because of the density of the color red. So what is with the density of color red? It permits adequate visibility of contents, giving maximum protection from the light. Okay, now, what are the examples of solutions or analytes that can be stored in a low actinic glassware? I don't know if you are all familiar with bilirubin. Bilirubin is a product produced by our liver, wherein if you extracted the blood for the bilirubin determination, you have to take note and you have to consider that bilirubin is a photosensitive one. Thus, therefore, if we are using or if we are collecting blood for bilirubin determination, we are protecting the sample, we are protecting the uh, serum separator gel from the light because of its characteristics of being photosensitive. Thus, we are covering the tube with a what you call this? Carbon paper. Now, if you have an amber bottle, that could be good for your bilirubin. Aside from that is, I will write bilirubin, carotene, vitamin A, B6, B12, folate, and porphyrins. Okay? Again, low actinic glassware is recommended for light-sensitive substances. Example of which is your bilirubin, carotene, vitamins A, B6, B12, folate, and your porphyrins. Moving forward, we have your Flint glassware, which is the last type of a glassware, which is composed of silicon, calcium, and sodium oxides. This is oxides, hindi oxides. Okay, oxides. Again, Flint glassware is composed of the mixture of silicon, calcium, and sodium oxides. Ano yung dito is ka na. Sika na Flint. Parang niyayaya mo na siya. That's a way to remember. Flint glassware sika na. No, silicon, calcium, and sodium oxides is the composition of Flint glassware. Now, aside from that, take note that it has a poor resistance to high temperature and chemicals. Usually, we are just using Flint glassware for storing reagents ng madalian. If you are familiar with this bottle, no, usually you're saying this bottle for ABO, for anti-sira. Okay, when we said anti-sira, well, of course, we're all aware of this. This is the reagent used for blood typing procedures. So ganito yung mga lagayan niya, right? A Flint glassware. Okay? Another example of a Flint glassware is your Flint glassware tubings. You can use this in as a stirrer. You can also use this in a what you call this? Tubing for your other chemistry experiments. Okay, wherein you are going to bore a rubber cork, and then you're going to insert the tubing, no, to eliminate the oxygen formed in a closed system na ginagawa mo for heating. Now, one of the characteristics of a Flint glassware is inexpensive, cheap in other words. Okay, inexpensive and generally used for reagent bottles like what I've said a while ago, and some disposable laboratory glasswares. The next in line is the one that we really hate, yung mga plastic. Okay, you're laughing because I am aware that you don't like that. But in the clinical laboratory, we have your glasswares. Plasticware rather. Plasticware is an alternative of our glasswares. Bakit? Cheaper eh. You don't have to clean, just simply dispose it. Okay? So, our plasticwares is composed, of course, there is an advantage and a disadvantage of using a plasticware. Let's discuss first the advantages of a plasticware. Number one, cheaper and more durable. Yun nga lang, like what I've mentioned a while ago, since this is a plasticware, we have to make sure that we are going to use it appropriately. Hindi yung mayroon kang disposable dropper, which is plasticware, and you are going to use that for strong acid solution. What do you expect? Eh, di natunaw yan. Okay? Aside from that, naman, on the other way naman, siya naman ay unbreakable and holds stronger alkaline solutions. So if it can be destroyed by acids, no, strong naman siya for alkaline solution. I just would like to share this experience of mine when there's a face-to-face wherein one of my students, I don't know kung nasaan ang utak ng batang iyon, iniwan ata sa bahay because ang ginamit niya is a disposable pipette for hydrochloric acid, and this particular student approached me saying, "Sir, natunaw po yung dropper." I asked that particular student, saan mo ba nilagay? Sa hydrochloric acid. And I replied with a great smile and said, "Wow, amazing." Diba? Now, how about the disadvantages? Cloudy, it's prone in cloudiness. Ay nanlalabo. Parang relasyon nyo, nanlalabo. Next in line is possible leaching of the surface. What do we mean by leaching? Leaching is a transfer of a chemical species from solid phase to the aqueous phase. Okay? And lastly, absorb certain dyes. Well, of course, I am sure naman na once in your life, you were able to use dyes. No, methylene blue in your anatomy and physiology classes. And if you're going to use plastic wares or plastic dropper for that, methylene blue, expect that this dropper will absorb the dye. Sometimes nga yung glasswares, ganun din eh. What more pa yung ating plastic wares. Okay? So again, these are your plastic wares. Advantage, cheaper, durable, unbreakable using alkaline solutions. Disadvantages, cloudy, prone to leaching, and absorb certain dyes. Moving forward to the types of our plastic wares, number one is we have your polyolefins. Okay? Polyolefins are unique group of resins. When we said resins, no? When we said resins, these are typically viscous substances that convert into rigid polymers. Okay? Through what we call curing process. Take note that resins are naturally occurring, but sometimes made synthetically. Okay? Polyolefins are unaffected by acids, alkalines, salt solutions, and most aqueous solutions. In other words, pwede siya sa lahat ng acids or pwede siya sa lahat ng substances regardless of their acidity or basicity level. The picture shown in this slide is an example of a polyolefin plasticware. Now, there are two types of our polyolefins. Two types. Number one is the polyethylene. And we have your polypropylene. Okay, so you have your polyethylene and your polypropylene. Now, what's the difference between the two? Take note, guys, that polyethylene plasticware cannot, no? I am writing it in a caps lock para matandaan mo. Polyethylene cannot be autoclave. And may tatlong exclamation mark so that you will remember that polyethylene plasticwares cannot be autoclave. Anong ibig sabihin po nun? Once you put it in an autoclave at 121 degrees Celsius, tunaw ang iyong polyethylene tunaw ang iyong polyethylene na plasticware. Sira ang autoclave. Well, on the other side, your polypropylene naman can be autoclave. No? Can be autoclave. However, it absorbs pigment. Absorbs pigment and become discolored. Yun lang yung problema. Pero you can autoclave. The purpose of autoclaving, I am sure naman that you are all aware of what is an autoclave, no? This is used for sterilization. Okay? Remember guys, there are two types of plasticwares. Number one, autoclavable. Number two, non-autoclavable. When we said, no? Autoclavable. Clavable versus non-autoclavable. Oh, what's the difference? Autoclavable can resist thermal temperature. Resist thermal temp. Example of which is your polypropylene, polycarbonate, and Teflon. How about non-autoclavable? E di, the other way around, hindi mo siya pwedeng i-autoclave. Polyethylene, ito yung example nun. Polyethylene, yung ating polystyrene, and our ponyl vinyl chloride or PVC. Polyvinyl chloride, yung PVC. Okay? So that's the difference between autoclavable and non-autoclavable. All right. So we have your polycarbonate. Polycarbonate is twice as strong as polypropylene. Polycarbonate can be autoclavable, diba? May be used as high temperature from 100 degrees Celsius to 160 degrees Celsius. Eh yung ating autoclave 121 degrees Celsius. Pasok sa banga. Okay? Polycarbonate, no chemical resistant, is not as wide as polyolefins. However, your polycarbonate is not suitable for acid bases and oxidizing agents. Take note, not suitable for acids, particularly strong acids. By the way, what do we mean by strong acid? How can we know that an acid is a strong acid? And how can we know if an acid is a weak acid? Yan. If you still remember the definition of your organic chemistry days, one of the discussion on that particular subject is how are you going to determine if a acid is a strong, if an acid is a weak? This is according to the definition of Arrhenius, no? Strong acid and strong bases, strong acids and weak bases. How do we define acid? Acid is the one where acid is the one that can produce hydrogen, no? That can produce hydrogen. Therefore, how are we going to define strong acid? Strong acid in a sense that it can lose completely. Okay? It can lose completely. Wala na siyang tinira. Ibinigay niya ng lahat. Strong yon kapag ganon. It can lose all of its hydrogen atoms. It can lose everything that it can have. It has. So let's say, for example, hydrochloric acid. Hydrochloric acid is an example of a strong acid. Why? It only have one hydrogen. And this hydrochloric acid can lose all of its hydrogen. Strong acid. Okay? While weak acid is, it can give everything that it have. Example of a weak acid that you are all familiar with is yung amoy ng mga pawisan. Yung mabahong amoy, yung amoy suka, maasim, yung acetic acid natin. CH3COOH. This is the chemical formula for our acetic acid. Ilang hydrogen? How many hydrogen do we have in acetic acid? We actually have 4. We actually have 4. But this acetic acid can only lose 1 hydrogen. Sir, si hydrochloric acid naman, isa lang din, yes. But it was able to give all of what it has. That's a strong acid. Okay? Nice to know lang, just to recall your organic chemistry lesson. Next is polycarbonate can also be used extensively in centrifugation. Next is we have your fluorocarbon resins. I guess this will be the last slide. Fluorocarbon resins are high corrosion resistance and can resist high temperature, 270 to I guess this is 255, to 270 degrees Celsius. Okay, making it a high corrosion resistance and resist high temperature plasticware. Okay? So ibig sabihin, it is not necessarily because it is a plasticware, it can't be resistant to heat. The other way around, it doesn't mean this is a glassware, it can resist thermal high temperatures. Okay? There are glasswares that can resist high temperatures, and there are plasticwares that can also resist high temperatures. At the end of the day, all of these wares, all of these plastic and glasswares have its purposes in the clinical laboratory, allowing us to do the things that we need to perform in order to test the samples or the specimen submitted in the laboratory. This will be the end of our today's discussion. Thank you very much.